Hello friends, welcome back. In my previous videos I have discussed about the concept of chemical kinetics, where we have come across concepts such as rate of reaction, rate constant, and derivations of rate constants, expressions for zero order, first order reactions, of course differences between molecularity and order of a reaction. Also we have seen other concepts on the concept of chemical kinetics. In this session, I am going to start and discuss the concept of Arrhenius collision theory. It has got one more name, that is activated complex theory. To understand this Arrhenius collision theory, we must have an idea in our background regarding thermodynamic and chemical feasibility of a reaction. Some reactions are spontaneous reactions. When I say spontaneous, it means they happen on their own. You need not have any external agency to conduct such reactions. Just to give a physical process example, water flowing from a higher level to lower level happens spontaneously. We need not have any external agency or agent to cause this change. Similarly, in chemical reactions, there are certain chemical reactions which happen on their own. They are called spontaneous reactions. To give explanation how these spontaneous reactions occur in nature, we consider two factors. Factor number one is thermodynamic feasibility. Feasibility, in other words, means possibility of happening. Okay. The second factor is kinetic feasibility. Thermodynamic feasibility gives us an idea based on the values of delta H, delta S, delta G. Particularly, the value of delta G decides whether the reaction is spontaneous or not. If we consider the standard value, that is delta G naught, if the value of delta G naught for the reaction is negative, then we say that the process is spontaneous. It happens on its own. If delta G naught value is positive, we say it will not happen unless there is an external agency. Unless you force it, the process will not happen. Delta G naught 0 means the process is at equilibrium. So this is from our previous understanding, which we have seen in thermodynamics of 11th standard chemistry. Now, if I consider a reaction and discuss about delta G naught depends once again on the values of delta H naught, temperature, and delta S naught. Delta H naught minus T delta S naught. This is the Gibbs equation. When we know the value of delta H, delta S, and temperature condition, we can say what is delta G value. Based on that, we can say whether the reaction is spontaneous or not. And this discussion gives us an idea about thermodynamic feasibility of the reaction. So, if we get the answer for a particular reaction as delta G naught negative, we may conclude that it will happen on its own. To give you an example, just a rough example, a fuel burns in air to give carbon dioxide, water, and energy. Since this involves release of energy, we can say this is exothermic. And also there is an increase in randomness, so delta S value will also be positive. Based on these two factors, we get the delta G naught value as negative, which means the reaction is spontaneous. But when we experimentally observe this, it will not happen on its own unless there is an initiation. Unless you initiate, the fuel will not burn just like that. Because there is fuel in open air, let us assume there is a petrol taken in a beaker or a cup and exposed it to atmospheric air. Now, air consists of oxygen, fuel is in our cup. Do they react with each other directly? No. Why don't they react directly? Though the value of delta G naught is negative, then comes the point of kinetic feasibility. Thermodynamically, the reaction is feasible, but kinetic feasibility is also another test which should be yes to undergo spontaneous reaction. So what is kinetic feasibility? This is this session's concept actually. So kinetic feasibility can be understood only when you know collision theory. So now I am going to discuss about the collision theory based on which we will understand what is kinetic feasibility. Later we will know whether the reaction is possible or not spontaneously. I have considered some of the summarized postulates of Arrhenius theory, collision theory. Let's see one by one. A reaction takes place only when reactant molecules collide with each other. So a reaction will not happen unless there is a collision between the reacting molecules. Second postulate says, not all collisions can cause product formation, but effective collisions. Molecules on their way collide with each other. That collision, if not in a proper orientation, then that will not lead to the formation of product. Even if the collision is not with the sufficient energy, that will not lead to formation of product. The collision which has the proper energy and a proper orientation only can be called as effective collision. So when there is effective collision between the reactant molecules, it leads to the formation of product. That was the second postulate. Then later, on effective collision, reactants form a higher energy unstable intermediate. So when they collide, they undergo excitation. They raise their energy to a higher level. That higher energy level will be unstable. We know this principle in chemistry, in science actually. When there is a higher energy for a system, it will be unstable. So a higher energy unstable intermediate, and it is called activated complex. I said just now that this theory has one more name, that is activated complex theory. That is because of the formation of activated complex, which decomposes into products. So once if there is a collision between molecules, if it is an effective collision, it raises its energy to a higher state called activated complex, which will decompose into products. So these were the postulates proposed by Arrhenius in his collision theory. Now we will see how to understand this with the help of a graph. Now I have chosen energy along y-axis and reaction coordinate along x-axis. I'll explain what is reaction coordinate. Before that, let us assume a reaction R gives P, which has a delta H value negative. Delta H negative means exothermic reaction. Purposefully I have taken this delta H negative because we were discussing about the kinetic feasibility based on the concept of thermodynamic feasibility. Okay, reaction coordinate you can understand from the basic definition of a chemical reaction. The definition was breaking up of older bonds and making up of new bonds, which means there will be breaking of bond between the two atoms during the reaction. So in reactants there will be breakage of bonding between atoms, and in product side we will have formation of new bonds between atoms. So if there is a breakage of bond between atoms, there should be elongation of the bond. So as the energy is increased, there will be increase in the distance of separation between atoms. Imagine there are two atoms in a molecule bonded through a covalent bond. As there is increase in energy, they must go away from each other. Finally, they will reach such a stage where the bond is broken completely. That is what is considered here as reaction coordinate. So for an instance, I can say reaction coordinate can be compared with bond length. So there will be increase in bond length, finally reaches the breakage stage, after which a new bond will be formed where there will be decrease in the bond length. So that is what happens during this explanation. Let us see energy along y-axis, reaction coordinate along x-axis, and I will consider the reactant energy somewhere here. Let's say there is some energy with the reactant already, which we call as average energy. This is average energy of reactants. because each reactant molecule will have its own energy. So we need to calculate the average of all the molecules. Further, as the energy is increased due to collision, when reactant molecules collide with each other, there will be increase in the energy of reactants. And that energy increase reaches a maximum state where we call the formation of activated complex happens. Let's say if A and B are the reactants, they form a higher energy activated complex. So instead of R, I will consider A and B as reactants. I'll give you the reason, because the collision theory is not valid for only one reactant reactions. Single reactant reactions cannot be explained using collision theory. So I have changed it to A and B now. Okay. Next, there will be decomposition of this activated complex into product, say C plus D. Some two products have formed. So when reactants collide with each other, their energy increases to a maximum called activated complex. That activated complex decomposes into products because it is unstable. Now there are 2-3 factors that we must understand from this graph. First one is, reactants do not have zero energy. Their energy was not zero. They had already some energy. And there is an energy gap between activated complex and x-axis here. That is from 0 to highest energy state. This energy gap from 0 to activated state is called threshold energy. Threshold energy. What is this now? The minimum energy that reactant molecules should possess in order to form activated complex and decompose into products. That is threshold energy. But reactants already have got some energy. We need to supply some extra energy to reach this. We need not have this total energy supplied to reactants. So that extra energy that is being supplied to reactants to reach activated complex is called activation energy. Activation energy. So what is the difference between threshold energy and activation energy? Is a very important point. Threshold energy is the minimum energy that reactant molecules should possess in order to form activated complex and decompose into products. Activation energy is the minimum extra energy to be supplied to reactant molecules in order to form activated complex and decompose into products. This is the extra energy to be supplied, and that is the total requirement of energy, threshold energy. Now this gives you an explanation of a reaction according to collision theory. There is one last concept I want to mention, and that is the difference between energies of reactants and products. This difference in energies of reactants and products is change in enthalpy, which we have seen negative in our reaction. There is a decrease in the energy from reactants to products, so that decrease is released, therefore delta H is negative. In case the reaction was an endothermic process, this curve would have been above this level. So somewhere here, that will have delta H value positive, where we need to supply energy. It will be endothermic process. So look at the graph once again. We will now see what are the different factors that may affect the reaction speed. Now let us see the factors that affect the rate of reaction and the factors that cause effective collision. There will be usually confusion between these two questions for students. Generally, they mix up the concepts or points while writing answers. So in order to avoid confusion, I have taken both the lists here. First is factors affecting rate of reaction, that is speed of reaction. Concentration of reactant. For reactions other than zero order reaction, we can say that rate depends upon concentration. Sometimes for the first power, sometimes for second power, likewise. So concentration of reactant, if in the beginning concentration is high, reaction rate will be faster. and vice versa. Next is temperature. Temperature causes change in rate of reaction. On increasing temperature, kinetic energy of molecules increases. So that leads to increase in speed of reaction. Pressure. This happens in case of gaseous reactions. When gases are reacting, greater the pressure, it directly relates to concentration again. So pressure causes difference in rate of reaction. Then catalyst. Upon adding a catalyst, say positive catalyst, the reaction speed can be increased. Reaction speed can be decreased by adding a negative catalyst. So catalyst alters the rate. Nature of reactant. Reactant's nature also matters. If it is a neutral molecule, the reaction speed will be slow because there is no polarity in the molecule. If the molecule has polarity, like ionic compounds, sometimes molecules with difference in electronegativities, they can undergo reaction faster. In fact, some chemical reactions in solution state also depend upon the nature of medium. If the reactants are taken in a neutral medium, the reaction will be slower. If the reactants are taken in polar medium, they happen faster. So these are some of the factors that affect the speeds of reactions. Now next concept is factors causing effective collision. This is our concept of collision theory again. Effective collision, which I said earlier, will be that during which the reactants reach a higher stage, higher energy stage called activated complex. To cause such effective collision, these are the requirements. Threshold and activation energy. If threshold energy level is very high, the reactants must collide with a greater energy. Otherwise, they do not reach the activated complex state. Next, proper orientation of molecules. Molecules must collide in a proper orientation. If a molecule is traveling along x-axis and another molecule from y-axis, the effective collision may not occur. If the collision is from x and minus x axis, that collision would lead to a proper effective collision. Then third point is collision frequency. Collision frequency, when I say, it depends upon number of molecules moving with very high energy. If there are more number of collisions in 1 second in a given volume, it is called collision frequency. Number of collisions, effective collisions per second per unit volume is called collision frequency. This can be compared with molecular speeds also. So these are the factors that can cause effective collision during a reaction, and these are the factors which can affect rate of reaction. Now we will continue the collision theory concept. Let's see the effect of temperature on rate of reaction. So I have divided this discussion into two parts, that is observation part and explanation part. What is the practical observation that we make during a reaction based on the effect of temperature? According to the observation, on increasing temperature, the rate also increases. This can be generalized like temperature and rate are directly related. Rate is directly proportional to temperature. So also there are observations like temperature coefficient. It is observed that for every 10-degree rise in temperature, there will be increase in the rate by 2 times or 3 times, which is called temperature coefficient. For every 10-degree rise in temperature, the reaction rate gets doubled or tripled. This is the observation during any chemical reaction. This can also be represented with the help of an equation, that is Kt plus 10 by Kt is equal to 2 R3. Here T is the temperature and T plus 10 represents 10-degree rise in temperature. So the ratio will be equal to 2 R3. This is the observation. how this is happening on increasing 10 degree centigrade temperature during a reaction, there will be increase of the speed almost 2 times or 3 times. So this is explained using the help of a graph. Okay, we will see the graph of this. Well, fraction of reactants is taken along y-axis and energy along x-axis here. Earlier we had energy along y-axis actually. Okay, there is a change. Energy is here this time and fraction of reactants on x-axis. Now what happens? There are molecules with different energies during the reaction and they show property like this. Well, here there is a maximum energy and that is the mean energy, average energy, but let's say there is activation energy here, somewhere here, say EA, activation energy, and only those molecules which possess energy greater than this EA can become product. So this area under the curve in this graph represents the molecules which are becoming product. Now what happens on increasing the temperature? This is an isotherm, which means at constant temperature T. Now if I increase the temperature by 10 degrees, there will be improvement in the curve like this. Okay, there will be a sloping of curve. But remember, the area under the first curve and area under the second curve will be same, because number of molecules is not going to change. Molecular number will remain the same, but number of molecules possessing kinetic energy, activation energy will become more. Okay, more number of molecules start acquiring extra energies required during reaction. So the area after this line will now represent the molecules forming product. So there is an increase in the area after effective activation energy line. So this many molecules now start forming product. Earlier that area was very less. Now that has increased, and it has happened when the temperature is raised by 10 degrees, T plus 10 degrees, let's say. Okay, for every such 10 degree raise in temperature, the reaction rate gets doubled because of this. As there is increase in temperature, there will be more kinetic energy for the molecules and there will be more effective collisions, causing more number of molecules becoming product. So this is the effect of temperature. Next we will have to observe what will be the effect of catalyst. So that effect of catalyst and concept of Arrhenius equation, numerical problems and other concepts of this chapter we will see in our next video. So that's all for today. Thank you so much.